So we are going to solve an exponential equation with like bases and solve for the exact value. So exponential equations with like bases, or we're going to have to rewrite them with like bases. So basically an exponential equation has a variable in the exponent, and there might be more than one exponential term. So the first one there just has a single x there up in the as the exponent there. You got 3 to 2x plus 1. And then the second one over there has 3 to the x plus 1 is equal to 9 to the x minus 2. So they look a little different, but we're still going to rewrite them with like bases and then isolate them. So let's work through a couple of different types here. So let's start with that first one there. 3 to the 2x plus 1 minus 5 equals 4. We're supposed to solve this exponential equation. So the first thing we want to do is we want to isolate the exponential expression. So let's get rid of that minus 5. So we get 3 to 2x plus 1 equals 9. All right, so now that we have it isolated there, we want to write it in terms of the same base. The same base there would be 3. You look at the smaller number there and think, oh, it's 3. Can I rewrite the larger number there in terms of that? Yeah, I can write 9 in terms of 3. 3 to what power is 9? It'd be 2. So it's 3 to 2x plus 1 equals 3 to the second. So that is all in part 1. Now part 2 says set the exponents equal to each other because you've got the same bases. So we get, say, 2x plus 1 equals 2. I can go ahead and subtract 1 from both sides. We get 2x equals 1. Divide by 2. X equals 1/2. Or if you prefer, x equals, you like a decimal, 0.5. So let's try another one here. We've got 3 to the x plus 1 is equal to 9 to the x minus 2. So the first one there, you've got an exponent on both sides there of the equation there. So can we write in terms of the same base? So the smaller number there is 3. Can you write the larger number 9 there in terms of base 3? Yeah, you can do 3 to the second power is 9. So since the bases there are the same, you have 3 to a power on both sides, you can drop them and you can say x plus 1, now we're on step 2, equals 2 times x minus 2. Use your distributive property, distribute the 2 through, and then solve for x. So I'm going to get my x terms on the left-hand side. So I get negative x plus 1 equals negative 4. I'm going to move the plus 1 on the other side, so I'm going to subtract 1. Negative x equals negative 5. I need x equals, not negative x equals, so I'm going to divide both sides by negative 1, and I get x equals 5. Next one here, again, we want to solve each exponential equation here. We want to get them to rewrite them with like bases. So they're already isolated there. Both of them have a power, both sides there. Smaller number, there's 3. Can I write the larger number, 27, in terms of 3? Yeah, 27 can be written as 3 to the third. Only problem is 3 to the third is down in the denominator, not up there in the numerator. So to flip 3 to the third up, you have to change the power to a negative. So it's going to become 3 to the negative 3. Now I can get rid of the like bases there, and I can say 6x minus 5 is equal there to negative 3 times x plus 5. I have to use my distributive property here and distribute the negative 3 through. So that's negative 3x minus 15. Let's get our x terms over on the left-hand side, so I'm going to add 3x. So we get 9x minus 5 equals negative 15. So let's get 9x by itself, so let's move the minus 5 away. So let's add 5 to both sides. So we get 9x equals negative 10. And then I get rid of the 9 there by dividing both sides here by 9. So I get x equals negative 10 ninths. If you like to put that as a decimal, go ahead and change that into a decimal. All right, we've got 2 to the x plus 3 here equals 1. So to write this in terms of the same base here, in this case, you can't really look at the smaller to the larger here. You've got a 1 there, and you can take any base and take it to the 0 power, and that will give you 1. So I can just replace that 1 there with 2 to the 0. So I'm going to write this down over here so that you remember this. 2 to the 0 equals 1. 3 to the 0 equals 1. 9 to the 0 equals 1. So if you ever have a base and it's equal, something to a certain power is equal to something there, you want to go ahead and say it's whatever that base is. In this case, it's 2 to the 0. So now the powers there, or the bases there are the same, so set the powers equal to each other. And we get x equals negative 3. So now we have 4 to the 5x minus 2 there equals 8. Can I write 8 in terms of base 4 there? Can you do 4 to a certain power? Well, 4 to the first power is 4. 4 to the second power is 16, so no. So maybe I have to go smaller than 4. What to the certain power can give you 4? Oh, 2 to the second. So I'm going to rewrite 4 there as 2 to the second. What about 8 then? Can I write that in terms of 2? Oh yeah, I can write that as 2 to the third, because 2 times 2 times 2 is 8. Now go ahead and set your powers equal each other, because now they have the same bases. So we can eliminate the bases, set the powers equal each other. We're going to use our distributive property now, so we can start to solve here for x. So I'm going to add 4 to both sides, divide by 10, and I get x equals 7/10, or I could do 0.7. So example 6 here. So again, we want to write these with the same bases, but let's go ahead and let's isolate the exponential expression first. So I'm going to get rid of this plus minus 1 here, so I'm going to add 1 to both sides. Now the exponential there is isolated by itself there. Now notice the bases could almost be the same, but that 5 over there doesn't have a power up there. What power is up there? Yep, it should be a 1. So now I can get rid of the bases there, and I can say 3x plus 7 equals 1. So now I can just go ahead and solve this thing for x. So I'm going to subtract 7, divide by 5, oops, sorry about that, 3x equals negative 6, divide by 3, and we get x equals negative 2. So let's stop here.